Hello everyone, welcome back to my channel. In the last video, we have gone through half adder. We have looked at the half adder circuit and how we can implement half adder with the Python. So in this video, we will be discussing about full adder and why we need full adder when we already have half adder. We will also look at its circuit diagram and how we are utilizing half adder to make full adder. We will also look at its application in various areas, though it will be very short, and we will see its implementation with the Python. So let's start with why we need full adder. So while we were discussing about half adder, you might be knowing that we were having a limitation. We can only utilize the two input A and input B, right? And we were performing the operation 1. Suppose it is 1 0, so our sum will be and carry. Sum will be 1 and carry will become 0. But suppose we are doing an addition operation on 1 0 and 1 wait a second, 1 0 1 and 1 1 1. Suppose this was the case and we were performing operation here. Okay, suppose we are performing operation here and we are getting 1 plus 1 as 1 and carry as 1, means in that condition input is A is 1, input B is 1, sum we are getting as 1 and carry we are getting as 1, right? But what about the second condition? This is the second condition where our input A is 0, input B is 1, but we also have a carry as 1. So our sum can't be like 0 plus 1 is simply sum as 1 and carry as 0. No, right? We need an extra third bit means to perform this operation. So here we will be utilizing the full adder logic. So before going into all the addition and everything, so simple thing we should discuss first. Suppose you are having the two number 1 and 2, how you will perform the addition? It is just simple, 2 plus 1 it is 3. Suppose you are having 1 2 and 4, how you will perform the addition operation? You will first add these two and the result of these two will be added to the third, right? So 2 plus 1 is 3 and then 3 plus 4 is 7, right? And same you can perform in other three, means other way also, like 1 2 4. You can add these two first. 4 plus 1 is 5, 5 plus 2 is 7. So there are multiple way to do the sum operation. So but you need extra place to store the result, means in first 1 and 4 result will be stored in separate and then further addition will be performed, right? So you need an extra 1 bit. So we know from the half adder that we can perform some operation using the half adder, means sum of 2 bit with the help of half adder we can perform. And what we are doing here, we are performing the sum of 2 and again the sum of the 2, sum of 2 and again the sum of the 2. So we will be performing the sum operation how many times? 2 times. So we will be utilizing the header, means half adder, how many times? 2 times. So let's look at the, means simply looking at how and what our sum and carry will look like if we have 3 bit. So let's look at our input A and we have our input B. These are two numbers, means 2 bit, and we are also having a carry. Suppose we are also having a carry flag there. So what will be our sum out and carry out? Right? So let's do our simple sum like we are doing generally in mathematics. 1 plus 2 first, and then the result 3 will be added to the 4 and we will get the result output as 7. So if we have our input A as 0 and input B as 0 and our carry is also 0, means there is no carry coming from the previous bit. So in this case what will be our output? So we will be doing 0 plus 0 0 and 0 plus 0 is 0. Sum is 0, carry is also 0. Suppose our input A is 0 and our input B is 1, but our carry is still not there. We are not having any carry from the previous bit. So what will be our sum? 0 plus 1, it will be 1 and carry will be 0. So same will be 1 and 0 and carry is again 0. So 1 plus 0 is 1 and 1 plus 0 again it will be 1 and carry will be 0. So let me write it quickly. Like 1 plus 1 it is 2 and 2 plus 0 it is again 2, but since we can't represent 2 in the binary, what we will do? We will simply do minus 2 it is 0 sum and carry out is 1. Let's see next. Suppose our input A and input B is 0, but we are having a carry from the previous bit. So 0 plus 0 is 0 and 0 plus 1 is 1. So our sum will be 1 and carry will be 0. And if this is 0, our input B is 1. 0 plus 1 it is 1 and our carry is also 1. So 1 plus 1 it is 2. We can't write 2. So 2 minus 2 is 0. Sum is 0 and carry is 1. In the second case, means this is I think seventh case. Yep. Seventh case. I think yeah, seventh case. So 1 plus 0 1, 1 plus 1 2. So again our sum is going to be 0 and carry is going to be 1, and if our both input is 1 and carry is also 1, we are getting carry from the previous operation. So 1 plus 1 is 2, 2 plus 1 is 3 and we can't write, so 3 minus 2 is 1, sum is 1 and carry is 1. So from here, do you see any pattern? If you have watched, I will not say again, you might have watched my video, so you might be understanding that we can see some gate in this operation. Some sorts of gate are there. If you see some sorts of gate, so if you see here, since there when carry is 0, we are only performing operation with the 2 bit. So you will see this as this is the XOR gate logic, XOR gate truth table, right? And this is simply the AND gate truth table, right? Since carry is not there, you can see this. Simple. So this is the simple half adder. Can we say simple half adder? And if we go further and see what is going on in the second case, when our carry flag is activated. So here we can see that, should I write it here? 0 plus 0, here it is 1, 0 plus 1, here it is 1, 1 plus 0, here it is 1, 1 plus 1, we are having 0 and carry as 1. Okay, so if you see the operation, what is going on? Right here, oh sorry, here it is 0, right? 0 plus 0, it is 0. Why I write like one? So if you see what is going on, 0, 1, both are alternate. So we are getting 1, 1, 1, we are getting 0, 1, 1. We are getting, since both are 1, it is same. So it is 0, alternate, it is 1. So what is this? This is again a XOR gate. Simple. So now coming to the next thing. What is this carry? Going slightly weird. So let's see what is happening here. So here 0 plus 0, we have carry as 0, right? 0 plus 1, our carry is still 0. 1 plus 0, our carry is still 0. 1 plus 1, here our carry become 1, right? And these all are our sum: 0, 1, 1 and 1. So let me write the carry from obtained from this side. So 0 plus 1, our carry is still 0. 1 plus 1, our carry become 1. 1 plus 1, our carry became 1. And here 0, 0 plus 1, again we are having our no carry, right? Simple. So from the second logic, we are not obtaining any carry, right? So now let's look how this is coming. How this is coming. So if you see 0, 0, 0, 1 and 0, 1, 1, 0, our output looks like 0, 1, 1, 1. Did you see any gate here? Yeah, this is our OR gate. So our resultant carry, when our carry bit is activated, is the OR gate, means is the OR result of the initial carry of the first two bit and the final carry of the resultant sum and the C input carry of the previous preceding bit, right? So let's make our circuit accordingly. So first thing first, we will be having two input, A and B, right? And let me put it slightly closer so that our drawing look not messed up. So this is B and this. So it will be having our XOR gate, right? And it will give our sum first. This sum will be feeding further and our carry will be coming from here A and B, and it will be passed to our AND gate, right? Now we know that our second sum will be again feeding through the second half adder, right? So this is sum 1 and our carry C input, this will be feeded here. From here we will get our final sum out. And what about our carry? 2. So this is our carry 1. So this is our AND gate, and this will come as our carry 2. But we know that our resultant carry is the OR gate of the carry 1 and carry 2. So what we can do, we can simply let me choose some other color. We can simply connect this and connect this to an OR gate, and this will be our carry output, means carry out. So I hope you understand how we are merging carry 1 and carry 2 to finally get our C out. So now next we will talk about application. Oh, application of full adder. So the first most application which we are reading till now is carrying on bit carry. We are calculating the carry. Second is basically encryption and decryption. Encryption and decryption. And mostly we can also use it in error correction, and there are several other way where we can utilize full adder, some in physical robotics component and many places they are used. So further we will understand how we can implement full adder using Python programming language. So let's move to the Python online terminal. Let's look at the full adder code. So this is the Python online compiler. I will share the link in the video description. You can go and check it out and run whatever query we are running, means whatever code we are running right now. So let's check whether our program is running or not. So we are getting hello world. So it is working perfectly. So let's start with our component. What are the component for the full adder? So first thing, we will be having input A, input B, and along with this input we will also be having C in, means carry input. Now our second component will be our XOR gate, right? Which we are knowing that we can use this sign for getting XOR gate. Now our third component here is AND gate. In Python we can get AND gate from this. And our fourth component, like you see in the screen, is our OR gate, right? We can use the pipe sign for OR operation. So let's start making our code. So what we can see, we are seeing three input. So let's make a function full adder which will be having input A, input B and C in, right? C input. Let's write like this. And what is first thing happening here? We are initially getting as sum 1. First sum we are getting. So what is our first sum? Our first sum is input of A XOR input of B. Correct? This is our first sum. This sum operation, it will again move forward to our second sum operation. And our carry 1 is equal to input of A and input of B. Now these are our first sum and first carry operation. Currently we have not input C in, right? So till now we can assume that this is our half adder. So now we will perform our final sum, means sum out, which is going to be sum out. So it will be equivalent to sum 1 and sum or no, sorry, sum 1 and C in, as you see in the figure. And what will be our carry 2? Currently we are not putting carry out. Our carry 2 will be sum 1 and C in. Right? Now we have to see our carry out. C out is equal to, what is C out? It is just the OR operation. So what is the OR operation between? It is the OR operation between carry 1 or carry 2. Right? Now we will be returning our answer. What is answer? Sum out and C out. Right? So now let's build our variable. So we are having input A as 1, input B as 1, input C as 1, right? So let's can I scroll it a bit? Yep. So we are having 3 input. Oh sorry, this is not input C. In fact, it is our C in. Sorry for the mistake. And let's call our function. So we will be having sum out and C out is equal to calling the function full adder and passing the value input of A, input of B and C input. Okay, and then printing our answer. So what is our answer is sum out and carry. It is C out. Now let's run our code and verify with our truth table. You can see the truth table in the screen itself now. So let's run it. So when our input is A, input B is 1, both are 1 and C in is also 1, then in that case our sum is 1 and carry is 1. Now let's change the input as 0. Input A as 0. Now what should be our answer? So if input A is 0, input B is 1 and C input is 1. So our sum should be 0 and carry should be 1. Right? Sum is 0 and carry is 1. And if both the input get 0 and we have only carry, so our sum will be 1 and our carry will be equal to 0. So you can verify this, and I think you can play with it. Both are 0 0 0. So this is all with the full adder code. You can also try it. I will share the link of this online compiler. So I hope you got what is full adder and how we can implement it using the Python script. So in the next video we will discuss about ripple carrier adder using the full means combination of half adder and full adder, and also completely with the full adder. So if you like, means if you gain some knowledge from this video, you can like. And if you want to motivate me, means if you want to motivate me, then you can subscribe to this channel. And if you don't like this video, means you have not gained anything from this, so you can press the dislike button. So I will be seeing you in the next video. Till then, goodbye.